All right, welcome to 5.5 Notes Part 2. Today we're going to be working on multiplying and dividing functions with each other. Our last section we dealt with adding and subtracting, and this is going to be very similar, you'll notice. So let's jump right into some examples that we can work together. So first, we're talking about multiplying f times g of x and dividing f by g of x. And it's also asking us to find that domain. And finally, just like last time, we're going to evaluate for whatever they tell us x is equal to. So starting with that, let's just for organization's sake, on the left side is where I'm going to find my f times g of x. And on the right side of the screen, I will find my f divided by g of x. So let's first start by identifying what is f of x. And if you notice, it gives it to us. It tells us that f of x is negative x to the third power. And g of x is 2 times the cube root of x. So just as you would expect, we write them next to each other in parentheses, a lot of multiplication problems you see like that. But it looks a little confusing like this, and I would much rather see this term written as an exponent. So we know from previous lessons that the cube root of x can also be written as x to the 1/3 power because of that third root. So let's just rewrite this as negative x to the third times 2 multiplied by x to the 1/3 power. Well, this negative indicates that there's a negative 1 there. So when we multiply our coefficients, we've got negative 1 times 2 gives us negative 2. And then how many x's do we have? Well, we know that adding exponents is what we do when we multiply those. So I've got an exponent of 3, and I want to add that to my exponent of 1/3. And I'm seeing a lot of people struggle with this skill, so I want you to think all the way back to grade school when we learned to add and subtract fractions. We have to have that common denominator. So I need this 1 right here to somehow match this 3 right here. So in order to do that, I have to multiply it by 3. And what I do to the bottom, I have to do to the top. So 3 times 3 is 9, 3 times 1 is 3. So I can rewrite this so that just to make it cleaner, 9 over 3, that's the same thing, plus 1 over 3. And that makes it super easy to see. So how many thirds do I have when I have 9 thirds plus 1/3? Well, I have 10 thirds. So I will fill that in over here. So my product of f times g is negative 2x to the 10 thirds. Well, if I divide over here, let's move to the other side of the page, and I still have those same terms. I have negative x to the third divided by, I'm going to go ahead and just write it as an exponent right off the bat. We've already seen that we can do that. Well, I've got my negative 1 divided by 2, so that gives me a negative 1/2. And now as far as my x's, well, I have that 9 over 3, that's the same thing as that 3. And this time I'm going to subtract 1/3. So 9 minus 1, how many thirds is that? 8 thirds. And there we go. So easy peasy. Well, then it also is asking us to find the domain. And when we are looking at an odd root, we know we can get negative values. So we will have negative infinity to positive infinity. And we're still dealing with that odd root, negative infinity, positive infinity. And finally, we're going to evaluate. So we're going to take that we just found, and we're going to evaluate it where x is negative 64, because that's the value it tells us it wants us to use. So we've got negative 2 times negative 64 to the 10 thirds power. You can do this in your head, and you would get the right answer, I'm sure, but there's no reason for us not to use the technology at hand. So we're going to use a calculator, and we will get negative 2,000,000 97,152. If you did not get that, it's probably just an error in entering it into your calculator. I'm going to remind you to put the exponent in parentheses, and it's also helpful to make sure you tell your calculator to multiply right here at this point. So then let's do the same thing over here. We're going to evaluate where x is negative 64. So I have negative 1/2 times, instead of x, I'm going to put in negative 64. And I'm going to raise that to 8/3 power. Plug it into my handy dandy calculator. You can press pause while you do that. And it should be up by now. You will end up with negative 32,768. Moving on, we're going to do one more example just like that where we find all that same information. So again, first let's identify what we're working with. This is our f of x, this is our g of x, and this is the value that it's going to ask us to evaluate it at. So on the left side, again, I'm going to do the f times g of x, and on the right side I'm going to do the f divided by g of x. So my f of x, that value we saw is 36 x to the 7/4 power, and my g of x is 4 times x to the 1/2 power. Okay, so pretty straightforward. We know that 4 times 36, you can use your calculator, and that'll give you 144. And then for our x's, well, we know when we multiply, that means we're going to add our exponents. So just some scratch work over here on the side. I've got 7/4 plus 1/2. Remember back to elementary school. They don't have the same denominator, so we have to give them the same denominator, manipulate it to make it that way. So I can turn that 2 into a 4 if I multiply everything over there by 2. So I know that 1/2 is the same thing as 2/4. So if I do 7/4 plus 2/4, how many fourths does that give me? It gives me 9/4. And that is my product. So if I were looking to divide those, I've already identified my f of x and my g of x. Well, 36 divided by 4 is 9. There's my x, and now I'm going to remember that I've got 7/4, and that I can make that 1/2 into 2/4. So 7/4 minus 2/4 gives me how many fourths? 5/4. And there we go. So now we're going to work on the domain, and the thing about this that's a little bit different from the last one is I'm not dealing with an odd base in either one of these. They're both an even base. So I'm saying base, an even root. So if I've got that even root, think about the parent graph of like a square root, or it's never going to give me a negative value. So I know that it's going to start at that 0, and then it is going to go on when it's even. It might look a little different than that since it's a 4th root instead, but it's going to start at 0 and go on for infinity. And it's the same root over there. It's going to be the same thing. So this one is a square root, not the 4th root, but that's just an example of an even root. Okay. And then finally, we are going to evaluate where x is equal to 16, because that's what it wants us to do. That's the value it tells us. And you can plug that all into your handy dandy calculator. You can pause this video for a second to figure that out. Remember to put a multiplication there. You might want to put that in parentheses. And it will give you 73,728. If it does not, check how you put it in the calculator. Get some help with that if you need to. And this time we're going to plug in our 16 for this one. So 9 times 16 to the 5/4 power. Again, just remember what you need to do in your calculator. Hit pause if you need to. you will get 288. Finally, we're going to look at this as a graph, and this says that the graphs of the function f of x, which is, let's see, f of x is this first one right here, this parabola, right there, tells us what that is. That's what the graph of that looks like. And the second one is g of x, which is this right here, your 4x minus 5. That's linear, it's going to go this way. And it's saying, well, which of these two graphs over here on the side, which of these two graphs are the one that is represented by f plus g, and which one is f minus g? So let's add them together and see what we get. So f plus g of x, well, I've got my values up here. So we're going to add them together just like we did back at the last set of notes. X squared minus 4x plus 4. And I'm going to add that to my g of x, which is 4x minus 5. I'm going to gather up my like terms. X squared. Okay, so that's good. And then here I've got a negative 4x and a positive 4x. Well, those add up to 0. I don't need to write them. And then a 4 minus 5 gives me a negative 1. Well, I'm looking, and that is exactly what this graph says. So I know that this graph represents that f plus g of x. So I'm going to assume that this one is probably f minus g of x, but we need to check that. We can't just say that it is because it's the only thing left, because it might not be. So let's see. F minus g of x. Well, we've got those same terms, our f of x. And this time we're subtracting from that our g of x. Well, nothing changed here. But this negative tells us to do something important. We're going to have to distribute that negative to each of those terms. So now that positive 4x becomes a minus 4x, and that minus 5 becomes a plus 5. Still have that x squared, but this time I have negative 4x and another negative 4x. So I combine those to get negative 8x. And I've got plus 4 plus 5 plus 9. And indeed, that is exactly what this graph says. So it is good to go. And you have finished all of the notes for 5.5. You are now prepared to complete the 5.5 practice.